Hey everyone, in this video we're going to go over critical paths and the critical path algorithm. It's a little bit trickier than decreasing time and priority lists, but it's similar in its own way. So what we're going to do is we're going to work backwards. We're going to be using the backflow algorithm to find the critical time for each vertex. So we're going to start at the end, and the end is 0. It doesn't take any time for us to finish, so the critical time for end is going to be 0. Now let's work backwards. If we go to G, in order to finish from G, from the time we start G to the time we finish the entire project would be 10 plus 0. So with G, we're just going to be at 10. And then let's do F. So from F, we're going to go from 6 straight to the end. So to get to the end, it's going to be 6 plus 0, which would be 6. Now for E, we go from E to G, and then from G to the end. So G was 10, and F was 6. So we're going to do 10 plus E. So 10 plus 3 is 13. So our critical time for E is 13. Now we're going to move on to D. So from D, we're going to do 1 plus 6. So critical time for D is going to be 7. For C, we're going to do 8 plus, we have to go from C to E to G to the end, so we're going to do 13 plus 8, which gives us 21. And then from B, we're going to go 9 plus 7, so we're going to have 16. And then from A, we're going to go from A to D to F to the end, so we're going to do 7 plus 4, which gives us a critical time of 11. Now, when we're at start, we have 3 different numbers. We have 11, 16, and 21. We're going to choose the critical time, the one that takes us the most time to complete. So if we were to just go through and do all of these with the most amount of processors, it would take us a max of 21 because that's our largest number. So 21 is our critical time for the entire project. So where is our critical path? If I were to ask for the actual critical path, it would be from start to C, to E, to G, and then to end, because this is the longest path. So our critical path is A. So now what we're going to do is we're going to create a decreasing time per se of our priority list, but instead of using decreasing time of the actual time for each process, we're going to be using the critical times. So let's create our list based on which one, A through G, is the largest. So we have C, then the next biggest number is B, then the next biggest is E, then we have A at 11, and then we have G at 10, then we have D at 7, and then we have F with 6. So now we have an essential priority list that's created, and we do it the exact same way as we would before. So we're going to come here and we're going to start. Which ones are eligible? A, B, and C. We have 2 processors, so the first processor is going to get one of these 3. Well, the first one we want it to get is C, so we're going to start with C. All right, now let's look at our choices. We have a C, and a C. We're all good, okay? Now our second processor is eligible to work on one of these other 2, so we're going to either have A or B. Well, we're going to take that other processor and it's going to get B, so we're going to start B. All right, so we're good on all 3 of those. Now the next one that we want to choose is, we're going to move along and then we finish C. Well, that makes E now is eligible. So we have A or E to choose from. Well, according to our decreasing time critical path algorithm, we're going to choose E first. So we're going to mark E. So there's E, there's E, there's E. We're good. All right, we're going to move along. We finish B. Well, we can't circle D yet. So the only one that's left for processor 2 to start working on is A. So we're going to start working on A, and then A, and then A. So we're going to move along, and then we finish E. So E finishes first. G becomes eligible, but we still can't circle D yet. So the only one that player 1, or our first processor, can do is G, because it's the only one that's eligible. So we're going to assign G. We're going to assign G. Well, this one right here assigns D. Well, we can't do D yet because D has to be after A completes, and obviously here we haven't finished A yet. So we know the answer is not C. So now we're just working with A and B. So we move along and we finish A. Once we finish A and B are finished, so we can circle D. All right, then we can go ahead and start working on D. So D is over here. And out of these two, D is the one, so our answer is B. And we can continue after we finish with D. We're going to continue on G, G. Okay, we're going to go ahead and start F, then we finish F, and we're still waiting on G to finish, and then G finishes, and then we're at the end. So this part right here, this path is the one that took the longest. As you can see, we didn't have any idle time here. If we just went straight down that path, the idle time was on the other one because this one actually was shorter. So what is the project finishing time? Well, the project finishing time is 21, which it actually just so happens to be our critical time. So explain why the time that we found in C is optimal. So why is it optimal? Well, when we use the critical path, our critical path was CEG to the end, which had a time of 21. Well, in this example, our finishing time was 21. So the quickest that we could have had it is just divide it in 2. And if we have a total time, all right, let's see. The shortest time in which a project can be completed by 2 workers is the total amount of work divided by 2. So there's nothing that's less than 1 unit of time. So we don't have a whole bunch of idle times here and here and here. So if we would have divided the total working time, which in this example was 41, all of those numbers added up, divide it by 2, and we get 20.5. So nobody actually works more than that. All right, we're going to do the exact same thing here, but instead of having a table, we're just going to find our critical path by working on the graph itself. So let's zoom into the graph. So to find our critical times, we're going to start from the end and we're going to use our backflow algorithm. So for K, we're going to have 21 to the end, so we're just going to have a 21 here. For J, we're going to have 3 to the end, which is just going to be a 3. All right, now from H, we have 13 to 3 to the end. So we're going to have 13 plus the 3 that was at J. So we have 16. All right, now we have D. Well, we can't quite do D yet because we don't know what G is. So let's go back. Now let's try I. So I is 6 plus 21, so we're at 27. All right, now we're going to go from E. We can only go one way. We can go from E to I. So we're going to have 27 plus 5, so we're at 32. Now we're going to have from F to I to the end. So we're going to have 27 plus 4, which is 31. All right, G, we have 5 plus 21, which is 26. All right, so now this is where it gets a little bit tricky. So from D, we have the option of going from D to G, which is 26, or D to H, which is 16. In the critical path algorithm, we're going to choose the one that takes the longest because we want to know what is the absolute longest that it could take to finish this project. So we're going to take 26 because 26 is bigger than 16. So we're going to do 26 plus our D. So 26 plus 7, which is 33. All right, now we're going to do 10, and we have a 26 or we have a 16. Again, we're going to choose the 26. So we're going to have 36. And then we have this 9. We either have a 32 or a 31, so we're going to choose the 32. So that's going to leave us with 51. And then we have this 2. We only have the option of going to the 32, so we're going to have 34. Now from the start, we're going to choose the largest out of these. We have a 34, 51, 36, and 33. So obviously we are going to choose the 51. So we have B, which is 9, and we only have a 32 or a 31 to choose from. So we're going to choose the 32 since that's bigger. So that's going to leave us with 41. A, we can only go from A to E. So we're going to have 32 plus 2, which is 34. So from our start to the finish, we're going to choose the biggest out of these 4 right here. And obviously 41 is the biggest. So our critical time for the entire path is going to be 41. Now let's go ahead and go down there. So we're going to go from start to 41. And then this one, we went down the longest path. And then the only path we had to choose from for the rest was here to here. So we went B, E, I, K, and then we got to the end. So now let's zoom out, and our choice B, E, I, K. And we get to the end. Our answer is B. So now we're going to schedule the project with 3 processors using the critical path algorithm, and we're going to give the finishing time. So let's look at these right down here. We're going to compare them as we go through. Let's do this the same way we did before. We're going to take and create our critical path decreasing time priority list. So we're going to start with the A, B, C through K, and which one is our biggest critical time. So our largest critical time is B, and then the next largest number, so let's go ahead and cross out B. The next largest number we have on here is C, so let's cross out C. The next largest we have is a 34, which is A. Then we have a 33 for D, 32 for E, 31 for F, then a 27 I, 26 G, 16 is H. Oh, I missed one. All right, so we go 27, then we do K. Then we do H, and then we do J as our last. So this is our new priority list that we're going to use to create our processors. So let's go ahead and erase everything that we have on here. And we're going to circle the ones that are eligible. So right now we have A, B, C, and D eligible. So we're going to start with B. So our first processor is going to get B. Our second processor is going to get C. All right, and then our third processor is going to get A. So we start, and then we finish A. So once we finish A, which one can we really do anything else except for D? D is the only next one we could do. So our processor is going to go ahead and start on D. So we have processor 1, processor 2, processor 3. Now processor 3 finishes, so it's going to keep going. So let's double check our graphs down here. So we have B, C, A, and D. We have a B, C, and A, B, C, and A, and then B, C, and A. Once processor 3, or whichever processor we choose, finishes A, they're going to start working on D, and start working on D, and start working on D. So far, we're all the same. Now, the next thing we're going to be doing is we move along and we finish processor 3. And we moved on to our D. We keep going, so now we are right at 9. So both of these right here, B and D, finish right at 9. So these two processors are now free. So we're going to finish B and we're going to finish D. Well, we finished A and B, so we can circle E. We can circle F. And since we finished D here, well, we can't circle that because we haven't finished C. So now E and F are eligible. So we're going to go ahead and put E and F on our graph. So we have E here, E and F. So we actually can't start G right here. So this one is wrong because if we start G, we have to have been finished with C. And we're not finished with C yet because C hasn't finished. We still have this little bit of time here. Now on this example, we stopped right here and we have E And can we do G? Nope, we still can't do G, so let's go ahead and cross that one out. And that creates our answer is Schedule A. And we can move forth and finish this if we need to. It will work out to be the same. The project finishing time is going to be right here, which is 41. Now let's move on to one more example. This one's these are tricky examples, but when you start doing them a couple times, they start working out. They all work the same way. So we're going to schedule the project using the critical path algorithm again. So it looks a little bit different. The end is down here at the bottom right instead of at the very far right. So let's zoom in and go ahead and create our times. So from the end, obviously, critical time is going to stay at 0. From F to get to the end, we do 0.6 plus 0, so that's going to be 0.6. This one is going to be 0.8 to go from here to here. And then from here to the end is going to be 1.6. These are the easy ones. Now we're going to go from E. The only place we can go is from E to F, so we're going to do 1.6 plus 0.6. So we're going to have 2.2. All right, now we're going to have B is 0.4, 2.2, so we're going to have 2.6 for B, and then to the end. Now we have C is 2.3, and the only way we can go is through F to get to the end, so we're going to have 0.6 plus 2.3, which is 2.9. Now we have D, which is 1.1, plus, the only way we can go is 2.2, so we're going to have 3.3. And then A, we have two choices. We have 2.6 or we have 0.8. Remember, with the critical path algorithm, we're going to choose the bigger of the two. So we're going to go this way. We're going to do 2.6 plus 1.4. So we're going to get 4.0. So now we're going to look at, we have 2.9, 3.3, 4.0, and 1.6. So our start critical path is going to be going from start to the A, which is 4.0. Our critical time for the entire project is 4.0. Now, once we have this, we're going to go ahead and create our critical time list. All right, our biggest number is going to be A at 4.0. And then the next biggest number is 3.3, which is D. Then we have a 2.9, which is C. 2.6, which is B. Then we have a 2.2, which is E, a 1.6, which is G, and then lastly, we have H, and then lastly we have F at 0.6. So A, B, C, D, E, G, H, F is our critical time priority list per se. So using the critical path algorithm, we're going to do this the same way as we did everything else. Now let's use a different color and go ahead and erase all this. Which ones are eligible? We're going to use 3 processors. So we have C, D, A, and G available. So the one we're going to start with is A. So A right here is going to be assigned to one of our processors. So we're going to start A. Then we're going to start D. And we're going to start C because we have 3 processors. So C, D, and A should all be in our first example. So we have C, D, A, C, G. So we don't want to do G yet because G is down here. We can do it, but it's way in the list. So we need to do D first. So this one right here is not going to be our answer. All right, and then we have C and then E and G. Let's look at E and G. We can't even do E yet because we haven't done anything else. And G, we don't want to do that one until we've done A. So we're going to cross that one out. Now we have C, D, and A. So all we're looking at is these top 2 right here. So we've already eliminated half the choices. All right, so we start moving along and we're right here and we finish D. So when we finish D, we can't do E yet because we have to finish all these other ones first. The only thing left for us to start is G. So from right here, we're going to go to G. There we go. Can we start B yet? So B has to come after we finish A, and we haven't finished A yet. So we can't do B. So that's our wrong answer, and our answer is A. So it saves us a little bit of time to eliminate the wrong answers. We could go forth with that until we finish. When we do, we get all the way down here, and our finishing time is 5. All right, now let's move on to the last example we're going to do with critical paths. So refer to the project described by the project diagram shown on the right. Complete parts A through E below. So we're going to do the same thing as before. We're going to start backflow. We're going to start at the end and move forward towards the beginning. So E is just going to be 2, J is going to be 7, and A is going to be 10. These are the easy ones. So now we go from 3, we have to go from D to E to the end, so we're going to be at 5. All right, G, we have to go 6 plus 5, so we're going to be at 11. We do 5 plus 5, so we're going to be at 10. And we're going to do 5 plus 10, so we're at 15 for this one. All right, we can't do this one because we don't know what H is, so let's do H is 6 plus either 11 or plus 7. So we're going to do it plus the 11 because that number is bigger. So we have 17. Now we're going to do 5 plus 10 or 5 plus 17. So obviously 5 plus 17 is going to be the bigger number. So we're going to be left with 22. And our largest number, 10, 15, and 22, is going to be 22, which gives us our critical path is from start to F to H. So start to F to H. So far we're all good with this one. We can eliminate that one and that one. And then from here we went down the 11 path, so that was G, and we can eliminate this one, so our answer is D. And we went all the way to the end from there. And the critical time for this project is going to be the length of this path, which is 22. Now the critical time priority list, we're just going to list these based on the largest numbers to the smallest. So our largest number is going to be F. Then we have B. Oh, no, sorry. We have H. Then we have B. Then we have G. Both C and A are the same. Then we have J, D, and E. So let's put these right here because these two are the same. We could switch those up. So we have F, H, B, G, A, C, or C, A. Either of these work. And then J, D, G. So our answer is A. So we're going to schedule the project with 2 processors using the critical path, and we're going to give the project finishing time. So we're going to go down. Okay, so let's copy down our critical time. Right here we had F, H, B, G, C, A, or we did AC. A, C, J, D, E. All right, so we're going to circle the ones that are eligible, which is A, B, and F. All right, if we have our 2 processors, we're going to choose preferably F first. So we're going to put F right here, which is a time of 5. We're going to move 5 out, start F. We move along, we have a second processor. So can we start H? No, but we can start B. So we're going to go ahead and start B. B is also going to be 5. We move along, we finish both of them. So cross out both of them. Now that we finished F and B, we're going to circle C and H. And we have A available, so we're going to do H first because it's in our list. So H6. And then we're going to either do C or A. Well, both of them are the same, so it really doesn't matter. We're going to do A, which is 10. We're going to go along. We finish H, so we can circle G and J. All right, now we want to do G, or we have A's already started. We have C. So do we want to do C or do we want to do G? Well, G comes first, so we're going to do G right here. And G is going to be 6. So we're going to move along. And then now we finish A. We finish A, well, we can't go any further, so A, processor 2 needs to be doing something, so it's going to either do C or it's going to do J. So in our priority list, C comes before J, so it's going to start with C, which is 5. All right, so far we are at 4 into G, so we have 2 left of G, so we're going to finish G. We finished G, we can't move on to D yet, so we're going to have to assign J, which is 7. All right, once we finish J, which is 7, we're going to go and we finish C. We can circle D, so D can go right here, which is 3. And then we have E at the end. So we are 2 left, and then we had 3, we had 4, so we're actually going to finish this one before we finish our J. And then we have E, which is 2, and we're 1 left over right here. So now let's look at our examples and see which one looks like the one that we just drew. So the only idle time we had was this little bit of idle time right here, where we had 1 time or 1 unit over. So if you look at it, it was this one right here, and this is where our idle time is. All right, so our total finishing time for this one is 25, which we could have just taken all of these numbers right here and added them up to give us 25.